Section 12.1 is on trigonometry functions and right triangles. Trigonometry is the study of the relationships between the angles and the sides of a right triangle. And the trigonometric ratios are fractions that compare the lengths of the sides. And you'll probably recall much of what we're going to cover today in this lesson from what we did in geometry last year. So here we have right triangle ABC. And you'll notice that in angle A up here, I've put this funny little circle with a line through it. That's actually the Greek letter theta, and it represents the measure of angle A. So, in relation to angle theta, side BC is the opposite, side AC is the adjacent, and while side AB is also adjacent to angle A, it is the hypotenuse because it is opposite the right angle. The hypotenuse is always the hypotenuse. So we have 6 trig functions. 3 of them you're going to be familiar with: sine, cosine, and tangent. And remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But now that we're in Algebra 2, we're going to introduce 3 more trig functions, and those are cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. So cosecant of theta is hypotenuse over opposite. In other words, it is the reciprocal of the sine function. It's the same as 1 over sine. Secant is hypotenuse over adjacent, and that is the reciprocal of cosine. And cotangent is adjacent over opposite, which is the reciprocal of the tangent function. And I kind of wrote that down here, that those are reciprocals. So here's how I remember it. Cotangent and tangent, pretty straightforward. Now, you would think that cosecant would be the reciprocal of cosine, but it's not. You have to just kind of think they're the other ones. So sine and cosecant, cosine and secant are going to be reciprocals of each other. Here's a little chart from your textbook. You'll be asked to memorize this later on, but these are the trig values for special angles. And you'll see our friends from geometry last year, the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. This is going to come up and be very helpful in, I believe it's section 3 when we talk about the unit circle. So let's do a couple examples here. This one says find the 6 trig functions for theta. Okay, so theta is the measure of this angle down here, and in relation to theta, I'm going to go ahead and label a few things. 6 is the opposite, 9 is my adjacent, and here's my hypotenuse. Okay, and to figure out the length of the hypotenuse, I'm going to use the Pythagorean theorem, and I did that over on the side and came up with 3 square root of 13. Okay, so sine of theta is going to be opposite over hypotenuse, or 6 over 3 square root of 13. I can simplify that to 2 over the square root of 13, but recall that I cannot have a radical in the denominator, so I'm going to multiply top and bottom by square root of 13, and that gives me 2 square root of 13 over 13. Okay, cosine of theta is adjacent over hypotenuse, which is 9 over 3 square root of 13, which simplifies to 3 over the square root of 13, and rationalizing that denominator gives me 3 square root of 13 over 13. And tangent of theta, tangent being opposite over adjacent, is going to be 6 over 9, or 2/3. Now, to make this easy, cosecant of theta, remember that's the reciprocal of sine. So I'm going to go back to this value here, 2 over the square root of 13, flip that, so the cosecant of theta is square root of 13 over 2. The secant of theta is the reciprocal of cosine, so I'm going to go back here to 3 over square root of 13. So this is going to be square root of 13 over 3. And cotangent of theta is the reciprocal of tangent, or 3 over 2. So I don't actually have to calculate those. I can just kind of flip the original, those first 3. Here's another example. In triangle ABC, angles A and B are acute, and find the remaining 5 trig values for angle A if the cosine of A is 3 over 10. Should have said it specifically, this is referring to a right triangle. So let's go ahead and just do a sketch of a right triangle here. Doesn't have to be super accurate, but I do want to label that that is the right angle, and I'm going to call that C. Doesn't matter which angle is A or B, they're the two acute angles. Okay, and I do know that the cosine of angle A is 3 over 10. Remember that cosine is adjacent over hypotenuse, so that means that my hypotenuse has to be 10 and the side adjacent has to be 3. Okay, now what I don't know is the length of the side opposite, but using the Pythagorean theorem, and I kind of did that off on the side here, I came up with the square root of 91. So from here I just need to figure out the other one. So I have cosine of A, so sine of A is going to be opposite over hypotenuse, square root of 91 over 10, and tangent of A is going to be opposite over adjacent, square root of 91 over 3. Now cosecant is going to be the inverse of sine, so that's going to be 10 over the square root of 91. Just the reciprocal, flip that, but I have to multiply top and bottom by square root of 91, so that's going to give me 10 square root of 91 over 91. Let's go ahead and do secant, which is going to be the reciprocal of cosine here, and that's going to be 10 over 3. And then cotangent is the reciprocal of tangent, 3 over the square root of 91. Rationalizing the denominator gives me 3 square root of 91 over 91. And the last couple examples here are going to be like stuff that you've already seen in geometry last year. So we need to use a trig function to find x in each of these triangles and round to the nearest tenth. So looking at this right triangle, one of my acute angles is 64 degrees, and then I have a side that is opposite, labeled x, and then I have the hypotenuse here, which is labeled 4. So what that tells me is, since I know something, or one of them that I have to find is opposite, and I know the hypotenuse, opposite and hypotenuse is sine. So the sine of 64 is x over 4. Solving that for x by multiplying both sides by 4, I get x equals 4 times the sine of 64, which is approximately equal to 3.6. How did I get that? I plugged it into my calculator. 4 times, hit the sign button, and then 64. Do check and make sure that your calculator is set in degree mode and it's not in radian mode. If your calculator is one of the rechargeable types and it completely died and you had to recharge it, it probably defaulted back to its original setting, which is radian. So hit that mode button, make sure you have degree highlighted. Second example here, I have a 48-degree angle, one side that is 22, and my hypotenuse is x. So in relation to this 48-degree angle, 22 is adjacent, x is my hypotenuse, and the trig function that uses adjacent and hypotenuse is cosine. So I'm going to set this up. Cosine of 48 is equal to the adjacent, which is 22, over the hypotenuse, which is x. This one's a little tricky because my x is in the denominator. So I have to multiply both sides by x and then divide both sides by cosine of 48. So that means that x is equal to 22 divided by cosine of 48. Plug that into your calculator and you'll get approximately 32.9. And our last two examples deal with an inverse trig function. So if you need to find the measure of the angle, use the inverse trig function. What this means is, if I know what the sine of an angle is, okay, then I can use the inverse trig function to find the measure of that angle. So in this case, I don't know what A is. I don't know what the measure of the angle is, but I know what its sine is. So then the inverse sine of whatever that value is equal to the measure of angle A. So let's try a couple examples here. So in relation to x is my angle that I don't know. I have 15, which is adjacent, and I have 17, which is the hypotenuse. So that means I'm going to be using cosine. So the cosine of angle x is equal to 15 over 17, adjacent over hypotenuse. I can't put that into my calculator, so I need to turn it into use the inverse, which basically says that x is equal to the inverse cosine of 15 over 17. And to get inverse cosine in your calculator, you're going to hit second cosine. And when I do that, I get that x is approximately equal to 28.1 degrees. That would be the measure of that angle. Let's take a look at our last example here. And again, I have x is the measure of the angle, which I don't know. 18 is adjacent. 27 is opposite. I don't know what my hypotenuse is, so that means I'm going to have to use tangent, because tangent is opposite over adjacent. So the tangent of the angle x is equal to 27 over 18. And I know I could reduce that, but I'm just going to leave it that way. So that means that x is equal to the inverse tangent of 27 over 18. And plugging that into my calculator, I get 56.3 degrees. So in this section, we took a look at the trigonometry functions that we use in right triangles: sine, cosine, and tangent, which we saw in geometry last year, and we were introduced to secant, cosecant, and cotangent, and how to use those to help solve triangles.